It's me again, W9RAN. I am kind of filling in. We had an opening in our schedule because N0SAP couldn't be here. And I got something in the last minute that was really kind of appropriate to share at this event. So I was going to just bring the thing along and point out a little bit about it. And what it is the little transceiver you can see down here at the end of the table. The only thing I had to do with it is it popped up for sale on eBay and I bought it. Because it doesn't take much when it says homebrew SSB to get my attention. And as I was first looking at it, I got curious about where it might have come from, because this was clearly not the average amateur undertaking to build a 3-band sideband transceiver. So I emailed the seller and said, do you happen to know anything about who built it? And he said, yes, it was Ernie Mason, W9RAN, SSB pioneer. And that intrigued me even more. So I had another conversation on the phone, a couple of emails with the gentleman standing over here, who is Dean Billing from Sisters, Oregon, right? I think he probably gets the award for coming the longest distance. And Dean says, I think I just might enjoy coming to that thing. So I'm going to turn this over to Dean, and I'm going to go over here and maybe wave my arms or something, and he's going to tell you a little about this radio and the man who built it. Dean.
Yeah, thank you. This is really a story of serendipity, truly. I was born in San Diego, and the first house I lived in, and I can barely remember it, I lived behind a gentleman, Ernie Mason, W9RAN, who lived in San Diego for the rest of his life. He was actually born in Missouri, was in the Merchant Marine in World War II, and settled in San Diego, went to work for IBM. And he's one of the few people, he was in field engineering, became field engineering manager of the San Diego branch office. One of the few persons who didn't, or few managers in IBM who didn't follow their motto, I've been moved. And so as I grew up, he became my mentor, and he's one of the reasons I got into ham radio. I'm WA6IKJ. And I moved a lot, but in high school I was back in San Diego, and at that time he was working on building a single sideband transceiver based on a BC453, or the Navy version of the ARC-V receiver. And I saw this little thing, and he lived about 2 miles from Ed Mariner. And Ed Mariner was a prolific writer, probably one of the co-founders of Western Amateur Radio. And if not, he had articles in Western Amateur Radio every month. He worked, I know he just asked Ernie if he could document his transceiver and then publish a little booklet so that other hams could build it. This was in the early days. This is about 60, 61, early days of single sideband. And of course, this was a rather unique transceiver because it could be built for very low cost. I can remember in high school, or rather after high school, he gave me my first job at IBM, and I worked summers in San Diego for IBM. And one day he said, come on, let's go down and look at this surplus store. I remember walking in it, and of course it had wall to ceiling had ARC-5s and SCR 274N receivers. So they were plentiful. You could get them for about $5, and if you followed this manual, maybe you could build a single sideband transceiver. Ed Mariner, even in here, says, no guarantees. It was a very difficult project. I built one during a summer, and I got the receiver to work very well, but we never quite got the transmitter to work reliably. Either that or I never had a good antenna. So Ernie spent his entire ham career building single sideband transceivers. And one of them is this tri-bander. I just sent Bob another one that is theoretically a 4 or 5 band transceiver. But he built, pardon?
There's no guarantees with it.
Oh, no. Well, the big problem is there was no documentation for this one either. I got it. It has a built-in power supply, so I was able to get fired up. The receiver worked. There was a wire hanging in it, and so I didn't want to try the transmitter. Bob has since done that and gotten the transmitter to work. But the other one that I sent him doesn't have a power supply. It's actually smaller than this one. It's more bands. It uses a Collins 455 kilohertz electromechanical filter. This one uses a McCoy 9 megahertz, serial number 15. So you know that Ernie worked on single sideband transceivers for many, many years, many varieties. I happen to know that he was a consultant on one single sideband transceiver that was going to go commercial, but the company never built it. I don't know the name of the company. When he passed away in 2000, his wife had to empty his shop. He had a big shop in the house he built in San Diego in Pacific Beach, but there were 2 transceivers that apparently nobody wanted. Other ham radio operators that Ernie knew came and cleaned out this shop, but left 2 transceivers. And several years later, she passed these transceivers on to another ham radio operator who lived in Redding, California. I didn't know him. Anyway, I reconnected with Joy Mason, and she said, this gentleman has these transceivers, but he's not really active in ham radio anymore. He doesn't know what to do with them. Do you want them? So I stopped by his house. I lived in Oregon. I stopped by his house, picked up the 2 transceivers, and then they sat in my shop for about 10 years. I'm obviously of the age that I have to start thinking about getting rid of all of the stuff I've collected for 75 years. And so I put this one on. I got the receiver working, put this one on eBay, and luckily Bob bought it and then contacted me, and so now we know the history of it. I am also a pilot and very interested in ARC-5 radios and SCR-274Ns, and I had the website scr274n.info, and I just took it down because I don't need that anymore either, but I had the all of the history of this and the manual on it, on the website, and a history of Ernie and some of his other stuff. I got some drawings of a couple of single sideband transceivers that he was working on, and they were all solid state, and one of them's really cute. But anyway, I've forwarded that file to Bob, and maybe he can make it available. It's about 40 megabytes. It's a PDF file, and it has all of this information. So, any questions?
What was Ernie's last name again?
Mason, M-A-S-O-N. Yeah.
So can you tell us a little bit about the design of the transceiver?
Yeah,
Yeah.
I can tell you what I have learned, which is not by any means all that needs to be learned. If I can get around here where I can point at it. The VFO uses a command set tuning capacitor, which I think most people who know capacitors will agree is still the best one ever made. I mean, you see these in Consett GSB 101s, and you certainly saw them in the Central Electronics. I guess we don't have one on display here, but the 453 VFO and the dress panel they sold. The McCoy crystal filter was considered to be as good a crystal filter as you needed for single sideband. It does use a 7360 balanced modulator, which again was kind of state of the art. They probably never made a better tube for SSB demodulation and modulation. The problem is it was not a 50-cent tube, so not everybody used it. Everything else was fairly straightforward with a couple of exceptions. The packaging, as you can see, is pretty tight. There's a 6CX8 audio preamp, audio power amp underneath the power transformer, or the audio output transformer. So you either have to be really adept with the fingers, or you have to take the transformer off to change the tube. But I'm sure he was looking at real estate, and that was what was available. The infamous red wire that Dean referred to was a speaker wire, but I think it never was hooked up other than internally, because there isn't room for a speaker. There's no sign that he tried to add one. So you do need that external. The power amplifier tubes are 6HF5s, which were used in Galaxies and Swans. Good way to get a bunch of sideband power. Mine are, well, I blew one of them up, I think, fiddling around with a bias, and even so, it puts out 100 watts. So not too shabby. The VFO runs at around 2.4, 2.5 range, and doubles to 5. The reason for that is if you take the 2.4 fundamental and you want to do if you want to do 80 and 20 meters, it's plus and minus 5 megacycles plus and minus 9, just the same conversion scheme that was used by Central. However, if you want to do 40 meters and you're doing a 9 megahertz filter, he shifted the VFO down to about 1.7 to 1.8, which could be done with just one capacitor. So now he can do a subtractive mix. The VFO is kind of all over the place. You got to do a lot of cranking to change when you change bands, but that's just the way it was. And you got a 3-band transceiver for not a lot of circuitry. The other thing that's unique, there are 2 controls, both marked peak, one there and one there. I've never seen this inductor before, but it's a multi-turn. You have about 15, takes about 15 turns. So it's obviously sliding a core back and forth in a coil. And I think he used those because it allowed him to cover 80, 40, and 20 meters without a bunch of fancy band switching. I think he does have a little band switch wafer on each one. One peaks the 12BY7 driver, the other peaks the receiver mixer, I think. So it's kind of reverse engineering fun if you like that sort of thing. I do. It's just like a puzzle, you know. You could sit and laboriously trace out the circuitry, which I don't usually do, or you could just poke around and learn what does what. So as for all my talk about SDRs, I still love this stuff. It's, I think, exactly what Wes Schum and Central Electronics wanted to promote, is guys getting on single sideband. And if you choose to buy one of their radios, that would be great. But I know from the presentations that Nick has shared, Wes did a lot of promotion of SSB as a mode. You know, it was a better way to use spectrum. It had all these advantages power-wise. And so guys like Ernie Mason went their own route, built their own radios, and I'm sure I would be surprised if those two hadn't shaken each other's hand at one point in time. Because I can't believe a guy who would do this would stay away from those meetings that we've seen, you know, with all these people listening to what Wes had to say. So that's the kind of story on the W6IQY. I will say I've read this book, and if I think Ed Mariner was an optimist. I mean, hats off to you're rewinding transformers, if I remember right. Very detailed, though. I mean, the documentation that Mariner did was very good, and if you got an interest at all in home brewing, this would be a challenge. It would be fun just to look at, because again, you've got detailed drawings of all the circuits, and he wanted to make it possible. I guess here's one of the modified 85 KCIF coils, and what things you modify on it to make it work. These are pretty good, pretty narrow filters in the command sets. The low frequency command set had the tightest filters of all, so that's why they were used as a tunable IF, or as an IF or a tunable converter, because you could either way get the advantage of that low IF. And there's a box sitting on my porch, which I'm anxious to go find out about. So thank you, Dean, and thanks for coming. Let's have a hand for Dean. Hey.
Does it work?
Yes, it does. Oh, yeah. Oh, yeah, it works. Receives well, transmits, burns up tubes.
Right. It works.
Yeah, it works. But that's what's fun about this vintage radio and collecting hobby is as you get into it, you run across things like this. And just looking at the techniques that these pioneers used in developing effectively a one-person product, and and the amount of cut and try that probably went along as he optimized each stage of his design. But anyway, we're going to move on now. No symposium is without some discussion about Central Electronics and West Schum, because that's the whole reason we started this whole thing. I believe I have a clicker that helps me out. Yeah, here we go. So what was it like before the world of ham radio, before single sideband? Well, you know, you were either on CW or operating AM. And operating AM was a tough proposition back before the war and after the war, in fact. You had to be extremely strong in order to get through, because it was just a sea of heterodynes. If you were on 75 meters, that's all you heard was tweets, noise, and to get above that, you had to run serious power. This was not the time to be QRP. You know, so you just got mashed like a grape, and so it was just a battle to be out there. You had to have a California kilowatt. The QRP rigs, no, forget it. Yeah, but there was some hope. Enterprising hams saw the opportunity of a different modulation technique that would eliminate the carrier and also eliminate one sideband. So it made it more spectrally efficient, but more important, it got rid of the heterodynes, which were the most annoying thing about trying to operate AM. You know, the AT&T was the one that really promoted the use of single sideband because they had the money and the horsepower to do it. And they used it for commercial telephone links, primarily across the ocean to link the United States with Europe. But it was just another way of conveying voice information. And of course, that's what people want to do, talk. We're doing a lot of that today, aren't we? But 1948 was really the year that single sideband hit the big on switch in amateur radio. QST had just one article after another, month after month, about the virtues of single sideband. Starting in January, QST of 1948, there were 3 articles about single sideband. You know, and before that, you really didn't hear very much about it. So 1948 and the League did a really big job in bringing the idea of single sideband to the amateur community. But there was, as Bob alluded to, there was a lot of resistance to it because it required a different way of detecting the signals. Now, home brewing was the way this was done. There was no commercial equipment back then in 1948. 49, even in 1950. The radios that people experimented with were all homebrewed. And they typically used the phasing technique. Some tried to use develop filters using surplus crystals that were used during World War II to try to make selective filters to eliminate one of the sidebands. But Don Norgard with the General Electric Company he's credited with making single sideband affordable for amateur radio and getting people to experiment with it with his single sideband junior, which was published in GE Ham News back in 1950. But to make it work, it's one thing to transmit it, you have to receive it. So he also built a companion, what they called a single sideband adapter, a slicer, and it allowed you to listen to either the upper sideband or the lower sideband, or to do what was commonly called as exalted AM detection, where you generated a local carrier and eliminated some of the fading problems with listening to AM, which with a diode detector receiver, if the carrier level or the signal level drops too low, you don't demodulate the audio and it distorts heavily. But little by little, folks were building these rigs. They'd congregate on the upper end of 75 meters, 39, 99.5 to be exact, lower sideband, which is about as far away as you could get from the AM as you could, because they didn't like them at all. And so it was a mutual hate-hate society at that point in time. So this is Don Norgard's single sideband junior. It's quite ugly, isn't it? But it was inexpensive to build. The neat thing about it was you got you on single sideband, but only on one frequency. It was crystal controlled. This one was designed initially to be on 75 meters only. And if you move frequency, you see all those little slugs in the front of that device? You would have to readjust the 90-degree phase shifter for the carrier, and it was difficult to move from one band to the other. Well, you couldn't with this. It was just a 75-meter version. He eventually came out with coil sets that you could do 20 meters. But this is what got it really moving. Lots of people built these things back in 1950 and 51. And more importantly, it got our friend Wes Schum's attention. Now, Wes, he knew that the single sideband stuff was important. He knew that it was going to revolutionize amateur radio. But he needed to make it where it was a product that you could actually efficiently use, that you could be able to QSY. You weren't stuck on one frequency. So as we'll see, he came up with a pretty ingenious way of doing it. And this, by the way, is Wes Schum. Picture of him at Central Electronics with his groundbreaking 100V transmitter, which we'll talk about a little bit later. So back to Wes. He had this vision. He was fresh out of the service. He managed to not get drafted in World War II until after the war ended. Then they drafted him. his luck. But he was involved in a company during the war effort where they built specialized equipment for the military. And he got a deferment because the work that they were doing was so important. So after the war, of course, the deferment went away, and Uncle Sam said, we've got a job for you. So for two years, he was involved in the Army. But while he was in the Army, he was thinking about, well, what can I do after this? What sort of business can I get into? Because he was always thinking about being an entrepreneur. He didn't want to work for anyone other than himself. So the result was Central Electronics. And the first product was this one, the 10A. Now, this was not band switched. You can change frequencies in bands, but you had to use plug-in coils. You changed the coil for the first mixer and also the final amplifier. So you'd have to lift the lid and unplug these coils, plug another set in so you'd be on a different frequency range. But the neat thing about it was to get away from having to effectively retune the sideband generator to achieve sideband suppression, he generated the signal at a fixed frequency, 9 megahertz. And he was the first one to use the concept of a transmitter or an exciter operating the same way as a receiver, where you had an IF frequency and you just mixed it up to different frequency bands to operate on in different bands. And he picked 9 megahertz to do this because if you had a 5 megahertz crystal and you use that as the local oscillator, then 9 plus 5 got you to 14 megahertz. 9 minus 5 brought you down to 75 meters. So with a 5 megahertz VFO, if you had a way of getting rid of crystal and building a VFO, well then you could cover both bands. It's a pretty neat idea. Now the 10A had some interesting features in it. It had voice control, the Vox. Not too many radios had Vox back in 1950. It had a device to eliminate the receiver audio from being coupled back into the microphone and tripping or keying the radio up errantly. We call it anti-Vox today. Back then they called it QT, like keeping it on the QT, or quiet. They developed we had to have a way of receiving it, right? So they developed another product called the sideband slicer, the Model A, which did the demodulation part. You would connect this to a receiver like a Collins 75A1, and you would be able to demodulate the upper or lower sideband, make a AM receiver into a single sideband one, and a quite good one at that. But the idea was he built this thing up as a system. It wasn't just you had to homebrew everything. He had it developed as a system where you could buy an exciter, a device to receive, and you're on single sideband. And he sold it either wired up or as a kit. Now, it's kind of interesting the way he did the assembly of these things. He lived on Giddings Street in Chicago, and apparently at the back of his property he had like a service alley, and his operation started in one garage. But then it grew. So he commandeered the neighbor's garage, and it kept growing. And pretty soon he had 6 garages, and these kids from DeVry University running up and down the service alley, collecting parts from each of these places, and they'd assemble it in one garage as a final assembly center. So he was quite ingenious in terms of building a factory out of nothing. But there are kind of interesting things that most people don't know about Central Electronics, especially back in the beginning, that he got access to General Electric's patents because GE had designed this concept of the single sideband junior and the slicer, but he was able to get them to allow him to use their patents and make improvements on it. And he was building these exciters as early as April of 1951. And actually, I have a prototype of one here, which if you take a little time later on to look at it, you'll see that the front panel and the layout is very similar to the 10A. In fact, it's almost identical. But it's kind of ingenious the way he did this is all the little coils that are in the 10A for the different stages, they're on little sub-assemblies, so you could modify them as he went along, as he developed a set. Kind of neat. Also, Collins Radio bought 10As. Most people wouldn't think, well, why does Collins Radio want to buy a 10A? Somebody else's single sideband exciter. Well, because these little 10As were selling like hotcakes, and guys were building them and putting them on the air like crazy. And Art was operating his KW1 transmitter, and a guy with a 10A with maybe a pair of 811s was just creaming him on 20 meters, just killing him. So he said, you know, we ought to look into this single sideband stuff. There must be something to it. And he developed a group that were doing research on single sideband, but they needed a way to generate single sideband signals quickly to do the research. So Art Collins calls up Wes on the telephone. And he says, "Hello, Wes, this is Art Collins. You know who I am?" I said, "Yeah, I've heard of you." Now, this is the way Wes was. You know, he had a pretty good little attitude about himself. And Art said, "You know, I understand that you build this transmitter, you call it a 10A. I said, "Yes, that's correct." He said, "Would you have a problem selling me some of those little sets?" He said, well, Art, we're having a run of these sets made now, but we don't have any assembled ones. Now, we do have some kits. Now, we could sell you some kits and send them up there if you have anybody at Collins that could assemble one." So Art said, "Well, I think we can handle it." You know, so sure enough, Wes boxes up 5 of these sets, sends them up to Art Collins, doesn't hear anything for weeks. Nothing, crickets. One day, he gets a phone call, and he said, "It's Art Collins again." And Collins says, "You know, Wes, we built these things. I know they work, but we can't get ours to work at all. All they do is produce a carrier." Well, they didn't read the instructions or realize the fact that it wasn't an on-frequency multiplier type transmitter. So they was just plugging in regular on-frequency crystals on the little crystal socket in the front. Well, it wouldn't generate single sideband that way. So they got over that hurdle, and he said, "Well, great. We got them working now, Wes. Can we buy 5 more? But this time, no kits." Yeah, you got to love those guys back then. You know, Bob Heil mentioned the fact that, you know, these AMers and sidebanders will almost come to blows, and it got really brutal at times. So Wes was promoting single sideband at a ham fest down in Georgia. And a group of these big burly AMers came up to him, lifted him up, one under each arm, because Wes was I guess he's about this high on me, picked him up, brought him over to Lithia Springs, and told him that they were going to immerse him in Lithia Springs unless he gave up this ridiculous notion of single sideband to replace AM. And he said, "Wait a minute, boys. This isn't going to work. This is the wave of the future. Put me down," which they did. They dusted him off, sent him on his way, but they were shaking their head that the single sideband wasn't going to go anywhere. And look where it is today. The other thing that's kind of unusual is that everyone thinks of single sideband or Central Electronics as just single sideband, but in fact they were looking at a whole range of products in its lifetime, and one of them was a novice rig, because novice class license was actually introduced in the 1950s. Wes's business partner at that time, Joe Batchelor, his engineer, really was anti this idea of doing anything other than single sideband. So he really pushed back on the idea of a novice rig, but eventually it did come to pass. And also a CB radio, and that was like, oh God, you know, why are we getting involved in CB radio? But they in fact did. So Wes was always looking for another angle to make Central Electronics a better operation. So let's move ahead a little bit. In 1953, he had a chance meeting with this guy from Georgia. He was about 6'2", redhead, very outspoken. He sounded like, and I met Joe in later years, he sounded like Foghorn, that, you know, a big bantam rooster. Say there, son, I say. Well, that's the way he talked. Yeah. Well, anyway, they met at a ham fest, and Joe had been developing his own little single sideband designs and had built a little single sideband transmitter to go in a car. Well, they got together and talked about different ideas that Joe had and things that Wes was working on, because Joe certainly knew him. In fact, you mentioned Bob, there you are, that, they must have talked to each other, these different experimenters, and absolutely did. There was a very open and free exchange of information about single sideband because it was so new. And everyone would kind of work together, and one idea spawned another idea. And that's how it was back at that time. So anyway, Wes had built this 10A, but it only runs 10 watts. It's designed to excite a linear amplifier. And he didn't have one yet. So he talked to the bachelor, and he said, look, Joe, we need to have a complementary amplifier. You got any ideas? He said, well, how about one that doesn't have a plate, tune, or load control? And Wes said, oh, this is different, because everybody had to dip the plate and tune the load to move frequency from one band to the other on a linear amplifier, any transmitter. So this was really kind of new. The only thing that was somewhat like that was the Collins auto-tune that was developed back in World War II, where you could have preset channels and a radio would retune to those channels. Well, this thing was done all electronically. So that got Wes's immediate attention. But also in 1954, moving ahead, Wes was not one to sit on a design. The 10A was selling like crazy, but it needed some refinement. So that brought about the 10B, which added a control in the front. So it allowed you to add some carrier where you were adjusting your linear amplifier and then take the carrier out without having to rebalance the balance modulator every time you did it. But that was a nice little improvement, but the real big change was this one here, which is the Central Electronics 20A. With that, he added band switching, because people didn't want to change bands by pulling coils out of this set and plugging new ones in. So this one actually has a band switch, and it covers all the familiar bands, 160 through 10 meters. And it also has a tuning indicator that was built into it now with a magic eye tube, so you could balance the carrier out without having to listen to it on a receiver. And it just was a much more refined setup. But that was what Wes tried to do with the Central Electronics product, always improve it, keep improving it to give more features and functionality to the hams. Again, these were all kits. You could either buy as a kit or as an assembled product. Now let's move to 1954, late 54. By this time, Joe Batchelor is really in the fold now. He's still down in Georgia, and Central Electronics is located up in Chicago. So they would work remotely in trying to develop this broadband amplifier concept, which turned out to become the 600L. And it was an amplifier to use a single 813. It operated 600 watts. It used the bandpass couplers that Joe Batchelor had designed, gotten a patent on. Degenerative cathode feedback system. That was slaved onto the band switch. So as you switched from one band to the other, it added enough inductance to null or cancel out the capacitive coupling from plate to grid that would normally occur when you'd have to neutralize the final. Well, you don't have that in a 600L. It does it optimally from band to band. A unique step-start circuit this was probably the first amplifier that had step-start circuit in it on the primary side to keep from blowing fuses in the power supply. Wes didn't like to overstress anything, so he always developed a product that none of the components were overstressed or pushed to the limit, and that's probably why they've lasted so long. It had a meter in the front, single meter, but it had multiple scales. So you would look at watts input, SWR, and antenna current. That way you know you actually were delivering power to your antenna. It had alarm indicators in the front. It had connectors on the back for TR switching, electronic switching, not just relays. And it had a electronically regulated screen current supply that actually was published in the ARRL handbook from 1959 up until about 1965. W9RAN, Tom Clements, was a engineer that worked for Wes, and he designed that circuit. Now the unit on the left over here, that's the 600L with the 1 meter. All you had for tuning was that band switch. So there's no plate and load. You just switch from one band to the other, 160 to 10 meters, and that's all you did. Now also in 1955, they said, well, now we got this band switched linear amplifier. We need to have a band switched exciter to go with it. So they started work on a no-tune 100-watt transmitter. They called this the 100V, V for VFO, 100 for 100 watts of power. Now the basic specifications for it were, it was self-contained power supply. Oh, wait a minute, hit the wrong button. 100 watts output, self-contained supply. All the modes this thing did: single sideband, double sideband, AM, phase modulation, and frequency shift keying. And this is in 1955. Think about that a bit. It had an active audio filter and speech processor in it in 1955. It used a tube to build this active amplifier filter. It had a built-in modulation scope, a very unique VFO that was self-compensating. As the tubes aged, it would automatically change the bias point on the VFO tube, the oscillator, and the buffer amplifier to maintain the output level as it aged, which was kind of unique. It got a patent. Instant transition from band to band. On a 100V, you can switch the band switch with the transmitter putting 100 watts to a dummy load and switch from one band to the other without blowing anything up. Because as you would rotate the band switch, it would bias itself off, cut the driver and the final amplifier off, so there was no power when you made the transition. They really put a lot of thought into this thing and made it as bulletproof as you possibly could. And it had break-in CW, FSK for RTTY. It was a phasing rig, just like the rest of these were, but it had a unique phasing network where you could get as much as 55 dB of sideband suppression with a phasing network, which was quite unusual. These little radios here, on a good day, you could get 40. Now, this single sideband was a big thing back in the day. And this is a picture of the 5th annual single sideband dinner in New York in 1956, which means that they started in 1951. And notice how these guys are dressed. This was a high-end deal. Coat, tie, the whole bit. Just like us today, right. Also notice something else. Everyone talks about the fact that amateur radio is an aging hobby. Well, there are not a lot of young guys in this picture in 1956. So I think the hobby renews itself. I don't believe we have to worry as much as a lot of people think. If you look back in the day, this is the complexion of amateur radio in 1956. There are a lot of young kids in it too. There are a lot of older gray-haired guys in it as well. And quite a crowd if you think about it. And these people came from all over the place, and travel back in 1956 wasn't as easy as jumping on Southwest Airlines and getting here, I can tell you. Now, Wes Schum The reason why I believe he's so important, and certainly the radios are very important, because it was so innovative. But what I believe makes Wes unique is that he really sold the amateur community on single sideband. He went to 110 different ham fests talking about single sideband and demonstrating it in a span of 7 years. Now that's a lot of traveling back then. Now this is a typical setup that he would have. You've got this one table, you got a 600L amplifier. Now bear in mind, this thing weighs 110 pounds. So, and you notice there's only this little skinny pipe holding this table up. So since these guys are really engineers, they definitely got the balance point right with this stack of gear on this side with a receiver, a speaker, a 20A exciter, the VFO, and the infamous sideband slicer over here. They use light bulbs as dummy lows to demonstrate the fact that this thing was putting out the power. Because there were a lot of people that said, well, it can't possibly work. It doesn't. You can't tune it. It won't have any efficiency. Well, yes, it did. And it was developed by this gentleman here. That's Joe Batchelor. Wes here on the side. They made a really remarkable team. So, by this time, things were going fairly well. 1957. They were still selling 10Bs. 20A exciters, they built over 5,000 of them, so they were selling really well. They had the 100V developed, prototype done, but the problem was they couldn't build it because they were burning through cash so fast. It cost a lot of money to build something that's as unique as that set was. They had to build their own test equipment to verify the design. It was just a very time-consuming, capital investive project. And the other thing is that they were selling through dealers. Back in the day that, things weren't as instant back then. You didn't have Amazon, and you didn't have fast ways of getting product to market. They used to use Railway Express to get these heavy transmitters around the country. So it was slow. They'd build it and sell it, and there was a big dwell time before they'd see a paycheck. And then when you're using dealers, you'd have to sell almost twice as many radios to make the same money if you were selling it directly. So they were going through cash, and they needed a big slug of money to make the first run of 100Vs. They couldn't do it. They needed to get an investor to buy Central Electronics. And that was, fortunately, when Carl Hassel and Zenith Radio came into the picture. Carl Hassel was the co-founder of Zenith and a very ardent ham. Called up Wes one day and said, look, I understand you've got this new product, but you need investment money in order to make it a product that actually hits the market. We're interested in it. Can you demonstrate it to us? So Wes and Joe packaged up the 100V prototype, brought it to Carl's house in Chicago, and got him on the air within minutes on 40 meters, making contacts. And he said, well, what about 20? Do you have an antenna for 20? No. You got some coax? So Joe and Wes built a stub to make the antenna tuned to 20 meters. And now he's band switching from one band to the other with the 100V without having to tune anything up. That was it. It was sold right away. Zenith made a deal. And that was when the exciting years for Central Electronics occurred, 58 to 61. They finally got the 100V built, built 1,500 of them, beginning in 1958, went all the way up to about the beginning of 1960, and then developed an improved version called the 200V, which I can show you in just a little minute. So there were 500 of those built. And this is what a 200V looks like. I'll have one up here on the table if you want to look at it closer. But what's interesting about it, it's all a desktop unit, self-contained, power supply here, this the PA. Final amplifier used a pair of 6550s, which were audio tubes that actually worked very well as linear amplifiers, very low distortion. This is the RF, low-level RF stage, where the heterodyne oscillators are located, mixers, they're here. Built-in monitor scope, VFO, which was extremely rugged and could be aligned every 50 kilohertz. So it tracked within a half a kilohertz from one end of the range to the other, which was a full 1 megahertz. Over here is the, whoop, where's my dot? Oh, it helps if your finger is not over the hole. Here's the audio section. This is the audio clipper and the active filter that makes up the speech processor. And this is the actual low-level single sideband generator stage. All broadbanded, utilizing the Bachelor broadband couplers. So, again, there was other things going on at the same time. They were actively constructing a new receiver, a companion to the 100V, which is called the 100R. It was designed to transceive with the transmitter. But that was being developed separately from Central by the Zenith military group, simply because they were trying to do so many things at the same time, they just didn't have the personnel to do it all. Joe Batchelor's group was working on the 2500L amplifier, the big brother of the 600L. It gives you an idea what power level it was going to be able to run. They also were developing a lower cost transmitter and receiver system, the 50V and the 50R. And it was scheduled to development also in 1961. So everything was really happening great for Central Electronics. Things were moving along. The 100 and 200Vs were in production and selling like crazy. At one point, they were outselling Collins 2-to-1, transmitter-wise. But then Zenith pulled the big switch. That would happen in late 1961. You know, when you have a company that's building television sets, and this is really the dawn of color TV in 1961, and they're selling $270 million worth of these in 61, and that's a lot of money back then. But the amateur radio group is selling maybe between $3 and $4 million. Do they really need that $3 or $4 million? And the answer to that was no, they didn't. So, December 29th, 1961 was when it all shut down. All the production shut down. There really wasn't even an announcement in the magazines. They just ceased to exist. But there was one radio that did survive. This fellow, his name was Robert Redfield. He was one of Wes's engineers. When Central was bought out by Zenith, you know, before the engineering team was Wes Schum and Joe Batchelor. That was it, 2 guys. They had some technicians, but that was all. When Zenith came to town, all of a sudden they went from 2 engineers to a half a dozen, and then from 4 technicians to 20. So everything just got scaled up. Lots of management too. So they had the people then to work on these different ideas and products. One of them was the novice rig. Well, this guy, Robert Redford, had prototyped the novice radio. And when Zenith pulled the plug, he took his 2 prototypes with him. And I'm glad he did. Because all we had really was a photograph of them. And even Wes wasn't sure what happened to the prototypes. He just knew they had them and just figured they were scrapped. But they were discovered. Up, lost the big thing here. Yeah, okay. Now, the first thing you notice, it doesn't look anything like a Central Electronics radio, does it? No. Well, there's a reason for that. And the reason is right down here. This guy here, Melvin Bolt and Associates. This fellow was employed by, his company was employed by Zenith to do the design work for all the Zenith TVs, cabinetry, as well as the stereo systems and radios from about 1959 to the last Zenith TV that was built in the United States. The thing about him was he loved to dress. And in fact, he was cited as being the best dressed businessman in the U.S. for 3 years. So he knew a lot about style, and he knew a lot about the direction that the industry was moving. And that's why this unit looks more like the contemporary Zenith stereo equipment of that era. It gave it a different flavor, a different appearance. So what about it? It's 90 watts input, CW with a little AM modulator in it, kind of like a DX60, you know? It had crystal, a VFO control. It was kiddo wired. That was the idea. Grid block king, so you wouldn't electrocute yourself when you were operating the radio. Some of the older initial novice rigs, like the night kits and all, you could have a couple of 100 volts across the key contacts, which eventually you did find. And they had a whole range of accessories that were planned for it, too. Now, I don't really know why you would want a DC power supply for a novice rig, but anyway, they thought they needed to have one. Now, the neat trick about the radio here, let me get in front of it. First off, it's this assembly here is backlit, so when you turn it on, it's lit up white. So you get this contrasting colors here. These knobs are backlit also. So when you're in the transmit mode, this area around each knob turns red. Now you have to think, this was a novice rig, and it was designed to catch a kid's imagination, because most people that were novices were young kids. So this was designed to get them hooked on ham radio. Now the neat thing about it was this little panel will pop off, and inside is the crystals. There are 4 of them. And because this guy was into styling, you'll notice that the crystals are angled so you could easily pull them out and insert new ones in. Yeah, I mean, they really thought about how this was going to work and how it should be better than the typical ham radio rig that you could buy at that time. The novice rigs were pretty basic then. These little colored lines, you notice that there's a frequency plan on this front panel, and you could slide these little markers along to coincide to what crystal you actually had plugged into your rig. So at a glance, you could tell, well, I've got rocks in here that does 50 meters, 80 meters only, or just 40. And it was magnetic, so you just snapped it back in, and that was it. It was really slick. Now, the prototype, well, I didn't have anything more about the prototype, but when Mr. Redford passed away, his son apparently knew about us and Central Electronics and that I was into collecting and restoring this and keeping the heritage of it alive. So all of a sudden, these just showed up in my front door. This one and its companion, there were 2, and he took both of them. This one was finished. His son actually used it, put it on the air as a novice. Well, yeah, he had no clue what he was using. And then the other one, which I didn't bring here, actually has a tag inside of it where the assembly lady put the date and the time that she stopped working on it, which was on the last day of the year at 3 o'clock in the afternoon. So I just left that one the way it was, because that's the way it should be. But, you know, Wes was very disillusioned, of course, when this happened, but it didn't keep him down very long. He moved into a whole different branch of manufacturing, building high voltage test sets that were used by AT&T, Bell Labs, Teletype Corporation, Motorola, and a whole lot of others. And he did it the way that he started out. He built all of this stuff in the basement of his house in Chicago. Pieces came in the downstairs door. He built his own chassis, punched out his own panels, did all the painting, did the silk screening, made his own circuit boards, etched them all, had them stuffed down. He had people that came in and did all this building for him. And out the door, eventually, would come out finished product, just the way he used to do it on Giddings Street with the first 10A. Thank you very much. Any questions? Yes, sir.
Any information why Zenith didn't try to sell it off?
Well, actually, West tried to buy it back from Zenith, but they wanted book value for it. So their idea of book value was several $1 million. And needless to say, he wasn't in a position to buy his own company back. Because of that, he also lost access to those patents. The broadband coupler had a patent along with the balance modulator that's used in 100V, the audio filter system limiter that had a patent. The VFO had a patent as well. A number of pieces and elements of the radio was patentable and had granted patents from Zenith, assigned to Zenith, but West didn't have access to that any longer.
What kind of price range were those?
What's that? The novice rig?
Well, the novice rig and the other.
Oh, the novice rig. They anticipated they could sell the novice rig assembled for $110 or $90 if it was a kit. The 200V, those sold for right at about $850 in 1961, which was a lot of money for a radio transmitter then. Yeah. Those are very inexpensive. The 10As were about $110. You know, the 20A was $250 because it had more features. The 600L was at about $600. I imagine the 2500L would have been $2,500. Yes.
So what are the key differences between the 100V and the 200V?
The key differences are the 100V had a tube-based power supply, 3 rectifier tubes, one of them being a 5U4 and the other two 6A AU4s. And the 200V had all solid-state power supply. The 200V had improved mixers. They had changed the mixer tubes to these new frame grid tubes that Amperex had developed, which reduced some of the spurious products that were evident in the 100V. But the 200V also was cost modeled, so they stripped some features out. You lost, for example, on the 100V, there's a position, a momentary position on the switch where you can look at the output level of the balance modulator to see if the carrier is properly balanced out. Most people didn't use it very often, so they took it out. They also did away with the double sideband because most people weren't using that either. So it's simple. Yeah, it simplified the radio somewhat. And also in the 100V, was built in individual chassis. So you had an individual chassis for the audio section, the sideband generator, the RF deck, and the power supply strip. The idea being they could build all these different assemblies up, plug them all together because they all had interconnecting plugs. And the idea was, well, you know, that way we could build them faster. It didn't work. It turned out there was enough differences from unit to unit that you still had to do a lot of alignment and things that just made it more difficult to build and costly. The other thing they did was they changed the knob assembly. They built their own tuning knob. Before they were buying the two-speed knobs from RME Corporation. If you look at, was it the RME 4300 receiver? It's the same dial mechanism. They bought them from them. But they didn't like it because it felt lumpy as you tuned it. So West developed his own assembly and deep sixed the RME.
How good a match did the 600L need to be efficient as far as the SWR?
Well, like a solid state rig, you know, 2-to-1 SWR would deliver the full power, but you could unplug the RF output on a 600L and it wouldn't damage a tube. Yeah.
I had a long conversation with Joe Batchelor in 1989.
Right.
He was living and working right outside of Atlanta.
Jersey, Georgia.
Pardon me?
Jersey, Georgia.
Okay.
Social circle, yeah, that way.
My intent was, I had heard that he works on these rigs still in those days, and I had one that, basically I picked up secondhand, and it needed a bunch of stuff done, including 160 meters added.
Right.
And I wound up shipping it to him via bus. He wound up shipping it back to me the same way, and it works, and it worked reasonably well. But he was one of those guys who you can never really have a short conversation with.
No.
Which was kind of surprising because I thought that he was quite aged at that point. And I figured he was busy because he had, I don't know what business he was actually in because clearly this wasn't the thrust of his main business, but he did have helpers and, he said he had sent one of his helpers or lackeys or whatever down to the bus.
Right,
Whatever
yeah.
it was. But he did say, as soon as we got on the subject of the tuning knob, he said, I am so sorry about that. I specified the wrong lubricant for those knobs. And I don't remember the details because he went into the great details of mobile oil number XYZBB, whatever it was. He said he specified the wrong lubricant, and he didn't realize that after X number of years they would all fail, and they all, of course, did. And so I don't remember too much of that conversation other than he said for capacitors, he just called up whoever was running Cornell Dubilier and said, I want the most microfarads you could possibly get into a can.
Right. There's 270 of them, yeah. 270 is how many jammed in that can, right.
So that was that. But it was a fascinating conversation, I must say.
Oh, he was a character. And the story about the lubricant, that was for the VFO. In the front of the VFO, there's a machine part that has 2 bearings in it, and it's preloaded to keep, and that's to get rid of backlash in the VFO. But they wanted to have a lubricant for it that would hold up under that stress, So they started talking, Joe started talking to these different oil company guys about lubricants. So they started sending him samples. And he had cans of oil all over the place. Wes even told me, and I said, I thought I was running a refinery. There was so many different cans of oil. So finally they set on one type of lubricant, and it turned out it was an oil that you use to lubricate the turbine in a jet engine. So they finally said, oh, this is great. The people that were trying to market this stuff to him, how much do you want? A gallon? 1 gallon did 2,000 radios. Yes.
Do you know what Wes's background is before he learned electronics and so forth?
Where he learned it? He was self-taught, like many of the people, the engineers at that time. He did go to college, but yes, yeah, right, yeah. It was a class in math, and that's where he met his bride. You know, yep, right. Yeah, and it was love at first sight. That was it. Yeah. He was enamored with radio at a very young age. When he told me stories about, well, yeah, he was 10 years old. He would run down on Ravenswood Street, which is where the Atwater Kent plant was, and he would hoist himself up, you know, on this parapet thing to look inside his little windows so he could watch what they were doing inside and building the radios. And finally, apparently, somebody saw him. And they invited him in, and he was in heaven then. Yes, sir.
What was the interest in Chicago? I'm from Chicago, in that area. I know where Ravenswood is, right? I can walk you there.
Yeah.
And then the Giddings Street, though, I was a year older.
2125. Yeah. Yep. It's all been redone now. You know, that part of Chicago got rebuilt, and so the housing is quite expensive there now. But I'm sure there's a resistor or two lurking in the backyard. Yes. Anyone else? Yes, sir. They were experimenting with it. You know, hams were allowed to use it on 10 meters, and they were using it up then. You know, the thought was, you know, lots of people were thinking that maybe it could operate it on 160 to get rid of the noise. You know, because it's so noisy on 160 during the summer, and it's, you know, you use an FM detector to receive it, so it has a noise quieting capability. But from a spectral standpoint, it's as wide as AM. Yeah. Oh, you see? Oh, Vox was extremely popular because the sidebanders wanted to use Vox so they could talk just like they were talking on a telephone, right? Very conversationally. Whereas the AMers would get on and do a monologue, you know, and guy might have the final locked down for 10, 15 minutes, you know, and everybody else is just sitting there, all right, waiting. He's got to come up for air eventually, you know. But with Vox, you know, it's just like breaking CW. Yeah. Yes.
Also, phase modulation was touted as one way of getting rid of TVI. And TVI was a huge
Right.
problem in the early 50s, way more than it was many years later, with 21 megahertz.
Yeah, 21 megahertz IFs on some TVs. Yeah.
Modulation, they couldn't tell who you are.
But they knew you were there.
I was also curious what the tube lineup is of the novice rig.
Oh,
It looks like a DX60. It looks like somebody took their inspiration from a DX60.
well, I mean, you know, when you have a basic radio like that, I mean, it's going to have a plate tune, plate load, and you know, but it used this one's got an experimental tube. They were into this, you know, because it was Zenith. All they had to do was just hint that they needed something that was unique, and all of a sudden it would just show up. Same thing with the 2500L amplifier. Wes had talked to Amperex, and back then Amperex was making these glass tubes in Holland, and said, you know, I need a tube that's got 800 watts of plate dissipation, that has very low NMOD products, at least 35, ideally 40 below, you know. And he said, well, gee, you know, 3 weeks later, this tube shows up. And it was an experimental tube. It eventually became a product that Amperex made. Now, this one uses a little bitty tube. It's like a 6146, except it doesn't have a plate cap. It comes from the bottom. But it works good, you know. The only thing I did was I recapped the power supply, and I plugged the crystal in, and I plugged, and I just arrived from UPS, well, you know how gentle they are, you know. So I plugged the crystal in, did not expect it to work. I hit the key, I'm watching the bird watt meter, and zoop, 60 watts, you know. So it was a good design. Now, Redford had also designed a 50-watt version of this that wouldn't have had the modulator in it, and he called it Galahad. This is Ivanhoe. Yeah. Yes. There was going to be, but it didn't get produced. Yeah. I've got the schematic for it. It's called a hot rod. Nothing else? Well, thanks very much. I certainly appreciate you all being here.